Hello, this is Gary Auden, and I'm bringing you an EDUcast, Better Room Design for Conferencing. It's sponsored by Revo and Telecom Reseller. With me today is Tim Mackey, Field Systems Engineer from Revo and we're going to be talking about the technology of the room rather than talking a lot about the technology of the devices. And we're trying to focus on room design today. And if you think about it, room design could make or break the technology. In other words, technology can't make up for poor room design if it's really bad. So let's start off with the first slide. What is so important? What are the challenges about room design? We're talking about acoustic considerations, physics of sound, components, room design itself, and some technical solutions. So let's move on. We're talking about audio all the time, but what is so challenging about setting up a room for good conferencing, Tim?
So there are many challenges today, but there are some basic ones we're going to go over. What you see there in front of you is a very high-end telepresence room. And, we like to say audio is our wheelhouse. It's probably the most important part. The A in the AV is very important. I had a fellow once tell me that if you lose audio in a room like this, you no longer have a meeting, you have surveillance. Whereas if you lose the video and still have your audio, you still have a meeting. So even in teleconferences, audio is the most important component to actually hold the meeting.
One of the points I think is important is this picture on the next page. What you're really saying is any room could be a conference room.
Absolutely. What I like about this illustration is it shows pretty much any conference room you will encounter in a corporate environment, whether it be from the auditorium to the large conference room, the executive office, the boardroom, small conference rooms. And today we're seeing more and more of the smaller huddle rooms or even touchdown rooms as they're called now. But today we're going to be focusing on the classic conference room or boardroom and talking about the audio for that.
Well, the next slide does present two pictures here, one of what you call traditional and then what I would call the modern room. What's different is changing over the years from the traditional to the modern rooms?
Well, unfortunately, as we move forward, people are kind of forgetting some of the importance of the basics of room design and going with what's more of a desire on for some other reasons. For example, people are liking transparency in the workplace, so more and more rooms are becoming glass or transparent conference rooms to show that sort of thinking. But these rooms are very, very bad for the acoustics, and we can talk about that a little further.
It seems like what you're saying is sometimes when they design the rooms for visual for everyone around, they're counterproductive for actual conferencing.
That's correct. One of the things we recommend and do want to talk about is you can't forget some of the basic principles in the meeting room. Even though they are going to these glass rooms, they're going to be a struggle because they don't have some of the basic audio principles.
What do you mean by the fishbowl effect?
Well, when you have a room like this, and this is again typical of what some designers are doing, you will sound on the far end like you're inside an echo chamber or a fishbowl because there's just too many hard reflective surfaces.
Now, when I look at this as well, what if we're not on conferencing? Does that also create clarity problems, just people talking in that room?
Yes, I think we've all experienced that before. When you're in a house that has no furniture in it, it's extremely echoey. When you're in a house that has furniture, carpeting, and stuff, it's less echoey. It's the same principle here.
So this seems the opposite of what you're talking about is if you have walls that absorb sound, it actually is a lot better than walls that reflect sound, like on the next page.
Absolutely. So whether you're in a theater environment at your local movie theater, and next time you're there, please look at the walls. You'll see acoustic panels. What you see on this slide are some examples and some very attractive ones and some very unique approaches to it. The top left, a typical auditorium. The top right is kind of a very interesting shape. It's more of an Art Deco, but it has an acoustic value to it as well. And the nice thing about acoustic panels, even the basic ones like in the bottom left, is they're very inexpensive, relatively speaking. We're talking about, some fabric and a frame on the basic end. And then if you look at the bottom right example, these folks have taken it to the nth degree. They have acoustic panels on a complete wraparound design in this boardroom. It's very modern looking, very striking, yet extremely effective, and it's, again, far from the glass fishbowl.
It sounds to me also like what you're talking about is you don't have to have acoustic panels that look like industrial plants for manufacturing.
That's correct. There's a number of them out on the market now. And again, I have seen folks be very resourceful and create their own as well.
Now, when we're talking about acoustic panels, we're trying to stop the sound bouncing around, and that's called reverberation or reverberance.
That's correct. When you're in a room or if you're in an open space out in the field, there would be very little reverberance because there's nothing to reflect audio back at you from. And the smaller the room and the more reflective the surface is, the greater the reflectance and reverberance is going to be. It's basic physics.
I notice in this picture here, you're pointing out even ceilings are a problem. Is that correct?
That's absolutely correct. So this illustrates some of the surfaces that would require acoustic treatment to be, of an optimum design. If you have a ceiling that's of a certain shape, I have been in buildings where the designer made a very pretty looking alcove ceiling, but it was a disaster to have meetings under it. So absolutely, the shape of the room and the materials used is critically important.
You bring up a new word on the next page called room criteria. What does that mean? Help us interpret that and understand it.
So absolutely. Room criteria talks about the background noise in any room or environment. And particularly for room criteria, we are talking about standards for conference rooms themselves. And we're really looking at the frequency range of 16 hertz to 4K. Human hearing is from 20 hertz to 20,000 hertz, but speech generally operates between 300 to 3,500, which is encompassed within what we consider here in the room criteria of about a 16 hertz up to about 4,000 hertz.
Does the acoustic, thinking back to the last page, actually help reduce some of the frequencies outside the normal range that could interfere?
Any reverberance of any frequencies is of a critical matter, but when we're talking conferencing and setting standards, we're really talking about this primary frequency range, which encompasses most of what you're going to be transmitting over a landline or a VoIP line or a teleconference.
Now, you go on to the next page here talking about ANSI levels. What are we talking about with all these numbers on the right and items to the left?
So here's some of the standards, and again, I'll be quite frank, these are not often met in rooms that I've experienced. Many rooms generally don't meet the RC requirements. So let's take a look at the very first one, a private residence. You would anticipate about a 25 to 30 decibel background noise in that room within those frequency ranges that we just spoke about. Now, if we scroll on down to conference rooms, a private conference room should be about 30 to 35. Business machines and computers are going to operate in 40 to 45. You can have rooms that have noisy HVAC, which will drastically affect these numbers. And these are very easy to check. You can download an app for most iPhones and Androids that will go into a room and measure the background noise quite simply for you. You'll be quite surprised if everyone's quiet in the room and you just run your little scanner on your phone, how much background noise there really is. My experience is we're generally seeing between 40 to 45 rather than what the standard calls out.
Let's look at that a little further. Here I have my little phone. I'm going around the room. Will I find that the noise levels vary within the room itself?
Yes, but not to a large degree. The largest impact is going to be equipment that's running in the room. Traffic can be close to a window. I've seen that be problematic before and push your numbers outside these recommended ranges. Anything that's, not supposed to be there.
What does RT60 stand for?
So it's really very simple, actually. What we're talking about is how long does it take a sound in a room to decay to the point where its reverberance time, what its reverberance time is equal to how long it takes for that sound to drop 60 decibels. So if I clap my hand and I make a 90 decibel sound, how long does it take that room for that echo to drop 60 decibels down to 30 dB? And we're looking at that time value. And this is really indicative of how reflective the room is. If you go into a room and clap your hands and it's really echoey, we would say that room has a long RT60 time. Again, if you could go into a sound studio where they have a lot of egg crate foam on the walls and it's designed to be very quiet, you clap your hands and you do not hear any echo at all. That room would have a very short RT60 time. Now, conference rooms are somewhere in the middle of that is where you want to be. Again, back to the NC value of the background noise, we also have a value for RT60. And we don't want it to be any longer than 1 second. The shorter it is, the better, down to about a half a second. Interestingly enough, I have been in some literally sound-tight studios where people will do podcasts from, and it's actually uncomfortably quiet. We are used to some level of RT60 and background noise.
You use the term decibels, and not everyone in our audience knows about those. What do decibels mean to us, and why is distance so important in talking about decibel levels?
Well, decibels could be tricky as they go up exponentially. Probably the most, and this is a very important slide, probably the most important aspect of room design is the inverse square law. And this is the physics we talked about. And it's very, very basic, really. It states that every time you double your distance between the audio source and your ear, or say your mouth and the microphone, you have a 6 decibel loss. So if I have a microphone, and this is the most important part in a room, is getting the microphones as close as you can to the speaker. If I have a microphone that's 1 foot away from my mouth when I'm speaking, and I move that microphone out to 2 feet, I have dropped in half or had a 6 decibel loss. If I move it out now to 4 feet, I have dropped it in half again, and now I am 12 decibels away. So from going from a microphone that's 1 foot away from your mouth and moving that microphone to about 4 feet away over arm's length, I have had a 12 decibel drop in that signal strength. So again, the inverse square law and placement of microphone to speaker in a conference room is, in my opinion, the most important element.
Now, we have talked about baffling and acoustics and the like, but it seems that what you just talked about will also be important in how you deal with echoes.
Correct. And real quick, echo cancellation is something very fascinating, and it's something that only comes up when you're in a hands-free or cordless environment. And what I mean by that is when you're holding up your handset to your head is the echo canceller. It's blocking the audio that comes out of the speaker of your phone from entering back into the microphone. Well, as you know, when we're in a conference room, we're going to have speakers maybe in a ceiling and microphones on the table. That's no longer the case. And if you're full duplex, the problem is, as the picture says, if client A speaks into his microphone, the sound is going to come out of the speaker to client B, but it's also going to go back into client B's microphone and be sent back to client A. This is what's known as acoustic echo, and you can tell it immediately in a conference room because it's about a second to a second and a half delay of your own voice coming back to you. What's interesting is this is the heart of conferencing. A good echo canceller in the DSP, and we'll talk about the equipment on a further slide, is the heart of the conferencing. This is what must happen. You must have an echo canceller to stop your voice being played back to you. Whenever you hear echo of this variety on a phone call, it is indicative of a problem on the other person's equipment. If you hear your voice back as client A, it is client B's equipment that is not doing the work, and vice versa.
Let's talk about that equipment, because a lot of people just think setting up a conference call is setting up a microphone, and that doesn't seem to be true.
Well, it's really quite simple. I know this diagram can look a little busy, but at the heart of the room in the center is the DSP, and that's the black box we're looking at. And there are many manufacturers that make those. The DSP takes the microphone inputs, which is up above. Now, we're showing a wireless system there because that's our bread and butter, but it could be just wired mics as well. In fact, we are showing both. It takes the microphone inputs, auto-mixes those, decides which ones to send at what time and how many to send, and sends them over either a network switch, if it's voice over IP, or out to a phone system. It will have, off to the left, a way to dial the phone call, and off to the right, again, very simple, the output from the far end is going to be sent to an amplifier and speakers in the room. Now, down at the bottom left, I've left in there the video conference tie-in as well, but we're really focusing on the audio today. But if you look at it in just these pieces, the components of a conference room are very similar, room to room, and pretty basic.
You have a term on the next slide which most of us don't understand, mix minus. Could you explain that, please?
Yes, so as we get into more advanced room setups, you're going to take, for example, let's talk about a a boardroom where we have a board of directors meeting. We're looking at the 12 board of directors in front of us. You're going to take the audio from those microphones and not just send it to the far end for an audio conference, but suppose it's a very, very long table. And the people, at microphone 1 cannot hear the people very well at microphone 12 down the end of the table. You don't want to be yelling at each other, so what we do is we take the audio from the microphones and we send them to the speakers in the ceiling, represented here as S1 through S6. Now, whenever you take a microphone and route it to a speaker and put the microphone under the speaker, as we know from going to a concert, you'll get feedback. So the mix minus refers to the fact, let's take microphone 1. It is sent to S3, S4, S6, and S5, maybe S2, but it is not sent to S1. That's because you don't need to hear yourself. You're trying to have your voice projected elsewhere in the room at a comfortable listening level to the others as if you were sitting next to them. So that's the minus. It takes mic 1, sends it to the other zones, that's the mix, but it minuses its own zone. So it's a term that refers to how you route microphone audio within a room so that anyone in the room can hear everybody else in the room at a comfortable conversation level.
Now let's move onward. You mentioned wired and wireless. What are the impacts there of those solutions?
Wired mics have been around for a long time, obviously. Revo Labs kind of invented the space of doing wireless mics. And again, it comes back to that inverse square law. The best place to have the microphone is as close as you can have it to the speaker. When somebody gets up to a lectern to speak, they're not speaking into a ceiling microphone. They're not speaking into a wall array. They're speaking into a directional microphone that's about 6 inches from their mouth pointed directly at them. So that's where Revo Labs comes in, is we give you the ability to take a microphone and set it anywhere in the room you need without the encumbrance of wires.
When I look at microphone types next, I think of the wearable. Aren't there people in conference rooms who can't sit down and keep moving around, and you have to solve that problem as well?
Yeah, we have microphone types for just about every solution, from a gooseneck to the flat microphones at the top are our omnidirectionals for a round table with folks sitting in a circle. And yes, we have a clip-on wearable that you can clip onto your lapel or your blouse, again, somewhere in the area of around a foot from your mouth. And that would be a perfect example of a presentation microphone that you could wear. But again, think back to that mix minus. You would certainly not want to walk around underneath a speaker that you are reinforcing that sound into with a wearable. So wearables have the consideration of, are they being used in a reinforced environment, or are you staying put at the front of the room and presenting with them? Most of the systems that I see put into conference rooms will incorporate some combination of a wearable and a much more significant number of table microphones. You might do an 8-channel system and have 7 microphones that go on the table and 1 wearable for when you do presentations.
That leads into the next comment. What's a crossover adapter, and how does it relate to wired and wireless?
So this is something that allows us to really blur the lines between the wired and the wireless microphone. Any one of our wireless microphones, and by the way, they'll give you a runtime up to about 16 hours on their AA batteries, the table mics. But you can also take the batteries out and use one of these permanent mount plates and have it plug in underneath the table and be always on. So we're taking advantage of the wireless aspect back to the receiver, but now you never have to charge this microphone. Think of a lectern where you might want to mount a gooseneck to it permanently. The lectern has power for your computer and a light for your presentation, so it's very easy to permanently mount a microphone there and not have to ever worry about charging it. Now the smaller triangle piece you see in that picture is kind of the hybrid between the two. You can leave the batteries in the mic, but now you can mount that little local charging wedge on the table. The wire can actually go out the bottom or out the back as seen here. And now you have a place for your microphone to live on its own little charging bud on a table or counter. The mic is live on that charging bud, so you could now have a meeting around the clock 24/7. And then when you felt like moving the microphone, you just reach over and lift it off, as it's just magnetic.
Does this help me set up a conference facility where I don't have to cable the microphones and I can move it around?
Yes, for example, I've seen training rooms where the tables are always in a reconfigurable situation. They may be in a horseshoe arrangement for a meeting one day, or they'll be in a tiered training arrangement another day. And they incorporated one directional microphone for each three-person table that was permanently mounted, and when they plugged the table in to give them USB power and power for their laptop from the pop-up on the table, the microphone was activated as well. So it just became another component on the table that got moved around when they arranged the room.
I've used the word distributed architecture a lot in networks, but I've never heard it applied to conference rooms. What does that mean?
The distributed architecture really refers to the fact that we have a remote antenna. So with the Revo Labs Elite wireless microphone system, you can pre-wire a room by simply running a single Cat5 from your equipment rack or your AV rack area to the room. You can pre-wire it into a single gang or a double gang box. What you see here is the transceiver that goes in the rack and the antenna that would be on the other end of that Cat5 cable. The antenna looks kind of like a Wi-Fi access point. It is paintable, and it is textured plastic that can be mounted on the ceiling or the wall. And it can go up to 328 feet, you know, the standard IEEE distance for Ethernet copper. So it's a very, very convenient system that we can now get audio in and out of that room over a single Cat5 to the antenna to our microphones.
You know, we've been talking about a conference room design, and you have a nice picture here. What are the major factors that make this conference room a good design?
Well, there's one step I would have taken it further, but what makes this room fabulous is a few things. One, they're using audio acoustic ceiling panels. Two, they have a nice carpet in this room as well. What would have been nice was to have the artwork be sound absorbing instead of a bit of reflective here. But there's enough going on in this room with the soffit drop and the carpet and the acoustic panels in the ceiling. There was also, behind this picture, some acoustic panels on this end to offset the display on the other end. And what you see on this table are our directional wireless microphones. You have one microphone for about every two speakers or attendees of the meeting. And you also see a touch panel for dialing. So this is typical for how clean it can be in a room without wires, with wireless microphones and a wireless tablet to talk to the DSP and control the room. So they essentially come in, they'll wake up the tablet, they'll push a button which will turn on the projector, start the conference, and then these microphones would be on a credenza on the charging dock until used, and then somebody would set them out a minute before the meeting, and off you go.
I'd like to just comment and recap what we've been talking about. Today, I think you learned a lot about acoustic paneling, but also the inverse square law and how it affects all the designs, the importance of the DSP and that design, especially in echo cancellation, and we've talked about how Revo Labs fits into this whole environment. There's an article that's worth looking at. It's called Why Sound Matters. This is the URL to it, and here's contact information for Revo Labs. I'd like to thank you, Tim, for your presentation today.
Thank you, Gary. It was a pleasure, and thanks for having me.